Hello, everybody. Okay, please get your papers ready. Today, we're not using the book, right? Today, we are looking at some other types of questions that are perhaps not in the book. So, yeah, we will be using the paper instead. So, please get them ready. Right, okay, so our lesson today will be on counting, right? And it will be from 5:30 to 6:30 p.m. It will be on. Okay, please stop spamming. I can see a lot of very bored individuals. Get your stuff ready. Okay, we will start soon. Okay, so yeah. Okay, with 1 more minute, right, we'll be starting soon. So get ready, and yeah, we will start when it's 5:30. All right, it's already 5:30 p.m. So everyone, let's get ready for our next, right, HAL Math weekly topic live stream, right, with me, Teacher Yong Lam. Today we'll be going through one topic that everybody seems to be a bit more struggling in, right, in their mock test, right? I have picked some common counting problems, right, and we'll be going through them today, right? So today we will be looking at this counting, which includes, right, one topic in your master book, addition and multiplication principle, as well as shortest path and enumeration, both being commonly mistaken questions from a mock test. Right, so without further ado, let's get started with the first type of problem, which is addition and multiplication principles. Now, just a bit of teaser, right? For my MHA and CO students, you will both be looking at this in the coming few weeks of the semester, right? So please keep a lookout on that, right? And yeah, what does addition and multiplication principle mean, right? I will explain using two examples here. So let's say one day teacher Yong Lam is very hungry, right? So he chooses to either buy a burger in Burger King or a burger in McDonald's, right? These are the choices that he has. Today we don't have any pages. We are not using the book, right? Because most of the questions are not from the book. Okay, anyway, right, I want to choose one burger. How many ways are there to choose one burger from Burger King or McDonald's? Think about it. Teacher Yong Lam wants to buy a burger from Burger King or McDonald's? How many ways can I buy? Right, very good job. I see some correct answers already. Now let me ask you, do I need to buy from Burger King and McDonald's? Right, teacher Yonglam only wants one burger. I don't need to buy from both Burger King and McDonald's. Right, the answer is a no. I only need to buy either from Burger King or from McDonald's. Either or, right? So if it's an either or case, right, we don't need to consider both at the same time, right? So I can either buy one from Burger King, 1 out of 7 from Burger King, or I can buy 1 out of 5 from McDonald's. That means in total, teacher Yonglam has 7 plus 5 equals to 12 choices, right, for the burger. Now, this is what we call addition principle, right? The addition principle is where you use addition to calculate the total number of outcomes if it's in an either or case. I don't need to buy from both McDonald's or Burger King. I just need to buy from one of them. All right. So this is the principle of addition, right? When we use either or. Now, the next day, teacher Yonglam is still hungry, right? This time, I only go to McDonald's and I want to choose one burger and one side. Now, there are, of course, 5 burgers for me to choose from and 3 sides for me to choose from. How many ways are there, right, to select one burger and one side? Now, what is different about this question? Is teacher Yonglam still choosing 1 out of everything? Or do I need to buy both a burger and a side at the same time? Yes, right. We need to buy both a burger and a side at the same time. So teacher Yonglam will need to choose 1 out of the 5 burgers and then 1 out of the 3 sides. So for every burger I choose, I can choose my sides. There are 3 ways. For every burger I choose, I can choose my sides. There are 3 ways. Right. So altogether, there are 5 times 3 equals to 15 ways to choose one burger and then a side, right? Choose a burger and then choose a side, or choose a burger and then choose a side, right? So this is where we use multiplication because I need to choose one and then the next, right? So when we are choosing one category and then the next category, we will use multiplication, right? So look for the words or and then, all right? So this is the basics of addition and multiplication principle. How will they come up in our GEP exam, right? Let's look at our first question. Now, at a workshop, there are 8 participants. Each of them shakes hands once with one another. That means every person will shake hands with each other. How many handshakes are there? Right. So as you can see over here, teacher Yonglam has already drawn up the 8 participants for you. And you will notice that teacher Yonglam is actually drawing them in a row. Right. How is this going to help us? Now, let's say that I have 3 students, right? I will make it simpler for you. Let's say I have 3 students, A, B, and C. Okay. Now, among them, I want each of them to shake hands with one another. So let's look at A first. A will need to shake hands with B, right? So that's one handshake. Who else does A need to have a handshake with? No page. Yes, today we are using a paper, right? Teacher Yonglam realized that A doesn't only need to handshake with B, he will also need to shake hands with C, right? So A will need to do 2 handshakes. There are already 2 handshakes involving, right, these 3 people. All right, so next, let's look at B. Now, how many handshakes will B need to make? Now, of course, B need to shake hands with A. But think about it. If A shake hand with B and B shake hand with A, are they the same thing? A shaking hands with B at the same time, that means B would have shaken hands with A as well. So this one handshake covered both of their cases, right? A shake with B, B also shake with A. Now B only need to shake one more time with C. So that's a third handshake, right? So you realize over here, actually, when we are choosing, right, how many handshakes there are, when we are counting, A shake hand with B is the same as B shake hand with A, right? I do not need to repeat again, right? In essence, I am actually counting the number of pairs of people I can form, right? Let me repeat. When I say handshake, choosing a pair, right? A handshake with B is the same as B handshake with A, right? So when we are choosing a pair, the order doesn't matter, right? So that's why I don't need to draw any new handshakes for C, because C already shook hands with A, C already shook hands with B, right? So that's the case for 3 students. Now we just need to look at what happens if I have more numbers, right? If I have 8 students, right? A, B, C, D, E, F, G, all the way up to H, right? So let's count the handshakes person by person, right? This is called the shooting method, right? What we do is, like what teacher Yonglam did, arrange everything in a row and then start from the leftmost person and count how many handshakes there are. Now, person A can shake hands with how many other people? That will be 1, 2, 3, 4, 5, 6, 7. Person A will shake hands with 7 other people. So from there, I have already counted 7 handshakes. Okay, so I just start from the left and look towards the right and see how many new people can I form handshakes with? How many new handshakes are there? Now let's take a look at the next person, person B. Now, do you think person B will also have 7 handshakes? Right? Do you think person B need to handshake with everyone again? Do we need to have handshakes with everyone again? Don't need, because you see, just now I said A shook hands with B, right? I counted it in our 7 handshakes previously. Now, when I start from B, B doesn't need to go back and shake hands with A again, right? Because just now A already shook hands with B. I don't need to overcount. I don't need to repeat. Now, who hasn't B had an handshake with, right? That will be the people on B's right, right? How many people are there? Teacher Yong has drawn 4, 5, 6, right? So B can create 6 more new handshakes with the people on her right. Okay, now hopefully you can see the pattern now. Let's look at the third person, right? The third person is C. Does C need to shake hands with A again? Does C need to shake hands with A and B again? The answer is no, because we already counted them when we were considering A and B just now. So where will C form new handshakes with? That will be with the people on her right, right? 1, 2, 3, 4, 5. There are 5 people on her right. So that means she can create 5 new handshakes. Okay, now can you see a pattern? I'm always looking towards the right. Can you see a pattern now? What will happen if I look at D? How many new handshakes can D form? Yes, 4, right? And then E, 3, F, 2, right? Okay, please write down your, answers in the chat as I keep going, right? G, only to the right, 1 person. H, 8, will this person form any new handshakes with other people? Well, there's nobody to her right, right? So it's 0. Okay, now in that case, I will just add up all the handshakes, right? Add up all the handshakes. 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. The answer is 28, right? Teacher Yonglam will have 28 handshakes among these participants. All right, so that is how you do this question, right? Whenever we are counting pairs, right? Choosing a pair of people, choosing a pair of stuff, right? For example, then you will just use the shooting method. Okay, stop spamming in the chat. I can see your answer. Okay, Wang Zijing, Q2R. Okay, now with that, let's move on to the second question. Now, the second question is very common in addition and multiplication principle, right? We want to use the digits 1, 2, 3, 4, 5, 6, and 7, right? And see each of the questions. How 2-digit numbers can be made if digits can be repeated? Now, this is a forming digits question. Sorry, a forming numbers question given a set of digits, right? And since we are forming 2-digit numbers, we will need to consider, right, what is possible for each digit. So let's list out all the seats, all the places, right? My tens place and my ones place, and consider one by one. And we do that by checking from the tens place first, right? So this time I'm looking at 2-digit numbers and digits can be repeated. So how many ways can I select the first digit? How many ways can I select the first digit? Take note, there are 1, 2, 3, 4, 5, 6, 7. 7 digits. So of course, I can choose 1 out of 7. So there are 7 ways to choose the tens. No page today. Okay? Next, let's take a look at the ones digit. I can still choose from 1, 2, 3, 4, 5, 6, 7 because digits can be repeated. So again, how many choices are there? There are 7 choices. So 7 for the tens, 7 for the ones. Is it 7 plus 7 or 7 times 7? That's my next question. Is it 7 plus 7 or 7 times 7? Now, teacher Yonglam is not choosing only one digit. I have to choose the tens and then choose the ones. I have to choose the tens and then choose the ones. 7 for the tens and then 7 for the ones. Choose one and then the next. So it is 7 times 7 equals 49 numbers, right? So there are 49 two-digit numbers. When digits can be repeated, it's pretty easy, right? Every digit, you can treat them as the same considerations, right? Every place, you have 7 choices. Right, this is still easy, but now I'm gonna amp it up by asking you, how many 3-digit numbers can be made without repeating digits? So I cannot say 111 or what, 223, cannot. Every digit in the number must be different, and this time there are 3 digits. So like what I said just now, we list out all the seeds and consider one by one, right? Starting again from the highest place value. Now this time, let's look at the hundreds place first. Hundreds place, I can choose any one digit from 1, 2, 3, 4, 5, 6, and 7. So there are, of course, 7 ways. But are there still 7 ways to choose the tens? There's still 7 ways to choose the tens, right? Let's say teacher Yonglam choose 1 already. Can I still choose 1 here? Cannot, right? I will have 1 less choice because my digits cannot be repeated. Whatever teacher Yonglam has chosen cannot be chosen again. So there are 6 ways to select this digit. Now let's say I selected 2, right? So 2 is gone. This time I have another 1 fewer choice for the next place, right? I have how many choices left? 1, 2, 3, 4, 5. 5 choices left. Right, and remember, I'm choosing the first digit and then the next and then the next. So I'm using multiplication principle. Now all I need to do is to get the value, right? 7 times 6 times 5 is 210, right? By multiplying all the number of ways for each place, I will get 210 as the number of 3-digit number. All right, so when you can repeat and cannot repeat digits, the consideration is slightly different. Hopefully you can see via these 2 examples. Now, honestly, there isn't much restrictions up till now, but let's look at the next question. Right, this time I am still working on 3-digit numbers, but I have a condition, right? I want 3-digit odd numbers and digits can be repeated, right? So same thing, we're gonna list out, right, the 3 digits first. But which place has a special condition, right? Which place is more special than the others? Which place has more constraints? This question is not only asking for 3-digit numbers, it's also asking for odd numbers. Guys, if it's odd numbers, can you tell me which position should I focus on first? Which position is more clear, more troublesome than the others? Which position should I start from? Yes, right. It is actually the ones, right? Because my one place must be 1, 3, 5, 7, or 9, right? In an odd number, which means we have a constraint. We have a limit on who I can choose for my ones digit. That's why I always start from the places with the special conditions. Okay. Now, guys, can you tell me how many ways can I choose the ones digit here? Remember, the number must be odd. How many ways can I choose my ones digit? Look at the digits you have, right? 1, 2, 3, 4, 5, 6, 7. I want an odd number. So then how many ways can I choose the odd digit? Right, I could either choose 1 or 3 or 5 or 7. So there are 4 ways to select the ones digit. Now, after that, let's perhaps look at other places, right? Does the other digits have to be odd? Actually not, right? It doesn't have to be odd. So we can just choose any digit over here. And I already said digits can be repeated. So all of the digits, I can freely choose them for my 100. So there are 7 ways. I can freely choose them for another 7 ways. And remember, I'm choosing one and then the other. So is it plus or times? Is it plus or times? Yes. So very good job. It's 7 times 4, and you can calculate it to be 196. Okay, good job, everybody. The answer is 196. Okay, now let's move on to the next question. All right, this time I'm still asking for 3-digit numbers, and I want it to be more than 400. And digits cannot be repeated, right? Let's list out our places and ask ourselves, if I want our number to be more than 400, which place has a special condition? Is it the ones, the tens, or the hundreds? I want it to be more than 100. 999 cannot, because I already said I only use the digits 1 to 7. Okay? So if it's more than 400, which place should I start from? Ones, tens, or hundreds? Which place? More than 400. Do you think the ones place is powerful enough to make it more than 400? No, we have to check the hundreds place this time, right? The hundreds place has a special condition. Can anyone tell me how many ways, or rather how many digits can I choose for the hundreds place? Yes, it will be 4 or 5 or 6 or 7. So there are 4 ways to select the hundreds digits. Okay, now everyone, stop spamming, please. Stop. You guys are being very annoying. Okay, very annoying. I don't like that. Okay, if you want to spam, you might as well leave. You're not here to learn. Leave. Okay, leave. Okay, now let's look at the tens place, right? For those who are still with me, how many ways are there to select the tens? Remember, I cannot repeat digits. Cynthia, 你在刷屏，你不要刷屏。Okay, so now 4 is the hundreds. Let's say I already chose the digit 7. So then I will have 1, 2, 3, 4, 5, 6. 6 more ways, right? So let's just choose 1 out of the 6 digits for the tens. And then 5 ways for the ones, right? Because remember, every time I choose a digit, I have 1 fewer digit for the next case. Okay, now with that, I can just choose 4 times 6, 5 is equal to 120, right? So there are 120 ways to select the 3-digit numbers. Okay, so with that, let's take a look at the next question, right? Remember, when we are choosing one digit after another, we use multiplication principle. Okay, now let's take a look at the next question. Now, this is not about forming numbers, right? So let's read the question together. There are 6 girls and 4 boys in class 1, and 5 girls and 8 boys in class 2. All right, now 2 kids will be chosen as flag raisers, but there are some conditions, okay? 1 from each class, including 1 boy and 1 girl. So there are in total how many choices for our flag raisers, right? How do we do this? This time, teacher Yonglam need to select 1 from class 1 and 1 from class 2. And also, one of them must be a boy, one of them must be a girl, right? I need to select 2 people. So, of course, we need to choose a boy and then a girl. The question is, did teacher Yonglam actually say who's the boy from? Or which class is the boy from? Which class is the girl from? I didn't, right? It could be, maybe I choose a boy from class 1 or a girl from class 2. But it doesn't have to be like that, right? I could choose my boy from class 2 instead and get a girl from class 1, right? So either cases would work, because if I choose like that, I can confirm I get 1 person from each class and there are 2 people of different gender, right? 1 boy and 1 girl. Right. Now, in this case, how should I calculate this? Teacher Yonglam's advice, consider the cases one by one, right? Just like Teacher Yonglam already said, there are 2 cases, right? Now, if you think your answer is 23, that's wrong. Think carefully, right? Let's consider each case carefully. First, let's say teacher Yonglam want to choose a boy from class 1. There are 4 boys, so I choose 1 out of 4. Then teacher Yonglam want to choose a girl from class 2, so I choose 5 girls, right? 1 out of 10. Now, do you think it's a plus or a times here? Am I choosing a boy or a girl? Or am I choosing a boy and then a girl? I need to choose a boy and then a girl, right? I need to choose 2 people in total. So I need to choose 1 out of the 4 boys and then 1 out of the 5 girls. So it's actually 4 times 5 equals to 20. Okay, so that's the first case. Choose a boy and then a girl. So it's multiplication principle. Next, I could also choose a boy from class 2, 8 choices, and then a girl from class 1, 6 choices. Choose a boy and then a girl. Multiplication principle, right? So it's 48. Okay, now we have 20 ways in case 1, 48 cases in case 2. In total, how many choices do we have, right? Well, your choices could come from either case 1 or case 2, right? 1 out of these 2 cases. So you don't need to say choose over here and then choose over here. So to combine and find the total, this time we will use the addition principle. We have the 20 from case 1 or 48 from case 2. In total, there are 68 choices. All right, so please make sure, okay, you read the question carefully. Is it supposed to be choose one and then the next, or choose one or the other? If it's and then, right? If it's and then, you use your multiplication principle. If it's or, right, you don't need to choose from both cases. You just choose one out of them. Use addition principle. And then use multiplication or use addition. Just like what we are going to do in question 4, right? It's again a hybrid of addition and multiplication principle. Now, using the digits 1, 2, 3, 4, or 5, how many whole numbers less than 1000 can be formed, right? If the digits cannot be repeated. Now, take note, I can only use the digits 1, 2, 3, 4, and 5. All right, so again, we might need to look at this question carefully. Now, some of you think, oh, teacher, I know, less than 1000, that means it must be a 3-digit number, right? Because it's something 100, right? If it's less than 1000, it should be something 100. I mean, it makes sense, right? But let me ask you a little bit deeper. How many digits can this number have? How many digits can this number have? Can it be a 1-digit number, or a 2-digit number, or a 3-digit number? Or could it actually be all of the above? Yes, very good job. Right, I see some of you already spamming the chat. Don't spam, okay? You can be a 1-digit number, 2-digit number, or a 3-digit number to be less than 1000. So, in other words, we need to consider the cases 1 by 1. Right, so for a 1-digit number, how many are there? 2-digit number, how many are there? 3-digit number, how many are there? So let's consider case by case, starting with the easier case, right? Let's say it's a 1-digit number. 1-digit number is also less than 1000, right? So I can just pick any one of these 5 digits to make a 1-digit number. So there are 5 ways, right? 5 ways. Easy, right? 1, 2, 3, 4, 5. 5 such 1-digit numbers. But what about the 2-digit number, right? This time, there is no specific condition. I just want it to be less than 1000 and cannot repeat digits. So I can still select 1 out of 5 digits for the tens. But for the ones, remember, digits cannot be repeated. So I cannot choose the same digit as the 10. Let's say I take away 5 already. Then I can only select from the 1, 2, 3, and 4, the remaining 4 digits. So it's 5 and then 4. And is it multiplication or addition? I'm choosing 1/10 digit, then a 1's digit, and then, so it's 5 times 4 equals 20, right? Multiplication principle. 80 is wrong, right? You have your 1-digit number to consider. 3-digit number, same thing. 5 ways to choose my hundreds, 4 ways to choose my tens, and how about my new ones this time? 5 ways to choose my 100, 4 ways to choose my tens. How many ways to choose the ones? Yes, 3 ways to choose the one, right? Your choices get fewer and fewer. So then 5 times 4 times 3 equals 60. Now, is my answer 60? No, my answer is not 60 because remember, you need to add up, right? Across all cases. I could have 5 1-digit numbers, 20 2-digit numbers, and 60 3-digit numbers. Combine them up, how many possible numbers there are, right? I don't need to form a 1-digit and then 2-digit and then 3-digit. So just add them up. there should be 85 numbers that you can form altogether, right? So my answer is 85. All right. So please take note, especially when you need to consider cases, right? Consider the cases one by one and then add up all the possibilities. All right. Good job. Thank God you understand. All right. Now, with that, let's take a look at some people keep on spamming. Don't spam. Be careful. If you spam too much, you will get banned. Okay. So with that, let's move on to the next topic. Right. The next topic is something that my MHA kids should have learned recently. My CO kids should already know. Right. It's called the shortest path. Right. What's the shortest path mean? Now let me use an example with one of my favorite Pokemon, Psyduck, right? So let's say Hungry Psyduck wants to get the cookie, right? And he has two roads to go to it, right? Road A or Road B. Can you tell me which route is shorter? Is it A or B? Right? Type it in your chat. Is it A or B? Answer me. Do you think A is shorter or B is shorter? Use your eyes to see, right? Is it A or B? Yes, it is B, right? Because you see, A is longer than B. You can count how many line segments were that, right, to reach the end. And B is shorter, right? But why is B shorter? Why do we call B a shortest path? That is because in B, right, Psyduck is always moving towards the target. He is hungry. He wants to get to the cookie. So of course, he will go towards the cookie, which is towards the right direction and towards the upwards direction, right? So we are always moving towards the target. You don't suddenly U-turn, right? You see in A, I'm going up, right, up, right, up. A, I suddenly U-turn to the left. When I move away from my target, no matter like how little it is, you will make your route longer, right? So a shortest path is always moving towards the target, which is why it's important to realize which directions you move from. Okay, and you cannot U-turn, right? So now, how do we calculate, right, the number of ways to get to the cookie in the shortest path problem, right? We want to find the number of shortest routes, right? I will recommend the number marking method. Oh, this is a bit hard to see. I will recommend this thing called the number marking method, right? Yes, how does that work? All right, so Judy, the previous question, please take note, right? You cannot repeat the digits, so it's not 155. Okay, so the first way, or rather the first step you do in this number marking method is to mark out all the points. In this case, it's pretty simple, right? It's the intersection of all your horizontal and vertical points, like what teacher Yonglam is labeling now. Let me make it bigger, in fact, right? Like where teacher Yonglam is labeling now is all the points of intersection between your vertical and horizontal lines, right? Which is where you can choose where you need to go next. Okay, now next we will want to label the directions. When I label the direction, think about, right, what direction should Psyduck go to reach the cookie? Remember, a shortest route will always reach towards the target. That's why, should you go up or down? Should you go up or down? Yes, you have to go up. Should you go left or right? You have to go to the right. All right. Now, next, we need to start considering the number of shortest paths for some specific points. Teacher Yonglan like to call that one direction points. Label the number of ways for your one direction points. Okay. Now, in this question, one direction points refers to, right, which points can you reach from your starting point using only one direction, right? So let's say this is your starting point, right? There's one way to reach your starting point, which is just to be there, right? Just be there. But which points can you reach from this starting point using only one direction? Okay, so you can either go all the way to the right, right? So then you can reach these points all the way to the right. So these are your one direction points. You can reach here simply by going all the way to the right. Okay, then you can also go up, right? These are also your one direction points. If you start from the starting point and only go up, this is your one direction point. Okay, so yeah, label up all the one direction points. From the starting point, there's only one way to reach these one direction points. And finally, we can start calculating for the other points, layer by layer. Okay, so for example, this point, how many ways are there to reach the center point here? How many ways are there to reach the center point here? You see, how many ways can I reach here? I can come from the left, or I can come from the bottom, right? For this point onwards, it's not a one direction point anymore. I can come from two directions, right? So in this case, I will just add up the number of ways, right? Then I can come here. There's one way to come here and then come here. There's one way to come here and then go up. So in total, 1 plus 1, there should be 2 ways to reach it. Similarly for this point, right? I can come from here, 2 ways to reach here and then go to the right. 1 way to reach here and then go up. So 2 plus 1, in total there are 3 ways. Okay. Now, continue with the next one, right? I can come from the left or from the bottom. From the left, there's 1 way. From the bottom, 2 ways, right? 2 ways to reach here and then continue. So 1 plus 2 is 3. Then the last point here, 3 ways from the left, 3 ways from the bottom. Altogether, there are 6 ways, right? So by simply labeling in order on the picture, you can find your answer, right? There are 6 ways to reach this point. Okay? And yeah, with that, let's take a look at the next question. Okay, so now the board gets bigger and bigger, and Ant is at point A. He wants to go to point B, but doesn't know which routes are the shortest. How many shortest routes are there? Right, so same thing, mark out all the points and label all the directions first. Right, the points are pretty easy, it's just your intersection. But if I want the shortest point, can you tell me which directions can I go? Up, down, left, or right? Up, down, left, or right? Right, which directions can I go? Up or down, left or right? Yes, you can go up and go to the right, right? Please label your directions. Okay, now, can you do this together with me and be slightly faster? Right, while I go through all the questions, can you also try out and then see if you can get the answer before me? Some of you already got the answer. Very good. Okay, so what point should teacher Yong Lam label first? Start from the starting point and find all the one direction points, right? So this is the starting point. There's 1 way to reach it. Then from the starting point, if you go only in one direction, which points can you reach? This is not in the book, right? All of this, there's no page. Up and right. So I can either go all the way to the right, right? One way, one way, one way. Or I can go all the way upwards. One way, one way, one way. Now, remember the one direction points are the points where starting from the starting point, only from the starting point, you go in only one direction, then you can reach it. All right. And now it's time to look at the other points again, layer by layer. So are you ready? Let's go. Right. So over here, Zijing, I give you a warning. Don't say, 1 plus 1 is 2. Then here, 2 plus 1 is 3. Here, 3 plus 1 is 4. Oh, the pen is a bit thick. Okay, now let's look at the next row. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. All right, now let's look at another row on top. Right, 1 plus 3 is 4. 4 plus 6 is 10. 10 plus 10 is 20. Right, so altogether there are 20 shortest routes. So altogether there are 20 shortest routes. So remember, just follow the steps, right? Mark out all the points, label the directions, and most importantly, find out all your one direction points. Then for the others, just look layer by layer, ask yourself, where can I come from? Okay, because sometimes it may not be bottoms up, I could go top down instead. So always think about it. To reach a certain point, from which points can you come from? Okay, you don't know how to do the shortest path? It's okay. You can listen to this explanation as well as try out our mock test, because I have a lot of questions in a lot of mock tests, right, on your shortest path question. Who knows? The next one might have another. Right. So with that, let's move on to the next question. Right. This time, in question 5, it's still pretty mild because I don't have any special condition. But let's look at question 6. How many shortest paths are there to go from A to B, same thing, go to the upwards or rightwards direction. But what's the special condition here? The special condition is without passing through P, right? So maybe there's a construction going on, maybe something's stuck. So I cannot pass through this point here, right? I cannot pass through point P here. All right, now with that, let's take a look at what will happen if you cannot pass through point P. If you want to avoid a point, if you don't want to pass through point P, what will happen, right? Well, every point has to have a number. So think about it. If you cannot pass through point P, there's no way to pass through point P, right? Because you don't want to come to P. You cannot come to P. There's no way to come to P. Then can you tell me, if I have to label a number, what number should I label here? How many ways are there to come to this point P? Given that teacher Yong doesn't let you to go to point P. Yes, right. What number can you label? Which number can you label to show that there are no ways? Label 0. Very good job, right? People have been telling me, yes, equals 0. If I tell you you have to avoid a point, it's actually the same procedure as before. You just need to mark the point that you need to avoid with a 0, right? So I mark here 0. The others are all entirely the same, right? So let's start off with the starting point and the one direction points as usual, right? So from the starting point, you find out all the one direction points. Starting point is here, right? You can go all the way to the right. 1, 1, 1, 1. Or you go all the way upwards. These are all your one direction points. There's always one way to reach them, which is simply by going along one single direction. Okay? Now, what's about the next layer, right? We calculate the one direction point already. Let's go to the next layer, right? I go on top. This is 1. This one, 1 plus 1 is 2, right? I can come from here, I can come from here. There are 2 ways to reach here, either from here or from here. Then we add up the number of ways, combine them to get the combined number of ways to reach this point. Continue. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5. Now let's move on to the next level. 1 plus 2 is 3. Do I need to care about this point? Don't need, I don't need to care. At this point, I definitely need to avoid. So I can just leave it as it is, right? It's just a 0. In fact, all the roads around it are blocked, right? You can block the road around it like what I'm doing here. Drawing across, or rather on all the paths that involves this point. Just so that you remind yourself, I don't need to care about it. Then look at this point. Now, this time, I can only come from the bottom, right? I cannot consider this path. I can only come from the bottom. So there are 4 ways. Then over here, 4 plus 5, 9. Now to the next level, 1 plus 3 is 4. 4 plus, remember, I cannot come from the bottom because I cannot even go here. So this is also 4. 4 ways to come here. I can come here directly. This is a 4. Then we move on to this point. 4 plus 4 is 8. 8 plus 9 is 17. Okay, next. 1 plus 4 is 5. 5 plus 4 is 9. 9 plus 8 is 17. 17 plus 17 is 34. Got it, right? The answer, there are 34 ways. You see, you don't even need to do much equations or whatever. It's just addition, right? Adding the number of ways, right, to reach each point. All right. And with that, let's take a look at the next question, right? This is still easy because if you want to avoid a point, simply put a 0 at that point and block off all the roads. Then do the rest as per usual. Just remember, there's a 0. All right. But in the next question, right, let's look at the next question. This time, I am starting from here, right? Mr. Johnson is here. Oh, where is it? And he is going to town B. But first, he has to stop by town A. He has to stop. Does that mean I label a 0 here? I don't go to town A. No, because this time I have to stop. I must I must stop at town A. If I must stop at town A before I can go to town B, how many ways are there for him to do so? Now, this time we need to plan a bit more, right? Because are we going from our starting point over here to town B straight away? No, we have to go from our starting point to town A and then to town B. So when the question say you must, right, pass through a point, essentially you are splitting your journey, your entire shortest path into two parts. First, you start from the starting point and go to the first stop, which is A. So from start to A, and then continue from A to B, from A to B, right? So you are splitting this into two parts. The first part is to find out how many ways are there to reach A. Then the next part, continue your journey from A to B. All right. So with that, let's first consider how many shortest paths are there from here to point A, right? Can you count? Use our previous method, right? First, find the one direction points, right? So these are your one direction points. But remember, you only need to consider from the starting point up to A. Anything beyond, you don't need to consider. So do you need to consider here? Actually, you don't need, right? Because if you come here, let's say I come here first. But remember, I have to go to A first, right? Then you realize, oh, at some point I need to U-turn. The moment I U-turn, it is no longer a shortest path, right? So I have to omit it. So basically, if it helps, you try to draw a boundary, right? That is around the region. Here, one corner is your starting point. The other corner is your A, right? Some of you have given the answer. Very good job. Okay, just give one is enough. I can see. Right, so then these are also your one direction points. Right, so we label 1, 1, 1, 1, 1, 1. The rest, do the same until you reach A, right? From the starting point to A, how many shortest paths are there? Do the same. 1 plus 1 is 2. 2 plus 1 is 3. Next row, 1 plus 2 is 3. 3 plus 3 is 6. Continue. 1 plus 3 is 4 plus 6 is 10. Now, once I come to here, I can stop. I don't need to count the top, right? Because if I count the top, then let's say I go this way, right? Like this. Oh, I realize I might need to U-turn later. That it's no longer a shortest path. Okay. So from the first stop, right? From the start to the first stop, I have 10 ways already. But that's only step 1. I need to move on to step 2, where I continue from A to B. This time, I shift my starting point. My starting point is A. And I, of course, want to go to B and see how many shortest paths are there. So we do the same thing, right? Label the one direction points first. But this time, should I still put 1 here? Think about it. Just now, in the first part, I had 1 way to reach here, which is just by staying there. But now, what's my starting number? How many ways could I have reached A? How many ways are there? Is it only 1 way? No, it is 10 ways. So I have 10 ways to reach here. I can continue these 10 ways to reach to my next one direction point. Continue my 10 ways to reach this one direction point. So for the second part of the journey, when you label your one direction points, it's no longer what, right? It is the result of your previous part. Likewise, if I go upwards, there are 10 ways to reach this one direction point. Then the rest, you can just do the same, right? 10 plus 10, 20. And then what's the final answer? What is the final answer? 20 and 10. The answer is, very good job. 20 plus 10 is 30, right? A lot of you are faster than me. You gave me the answer already. Good job, right? So my answer is 30 ways. Okay, so there are 30 ways to reach point B by passing by point A first. All right, so this is shortest path. In this brief lesson, I have covered 3 types of shortest path questions, right? The normal ones, the ones where you have to pass through a point, the ones where you have to avoid a point, right? So if it's normal, just start from the one direction points, right? Start from the one direction points. add up for the rest. If it avoid a point, please remember to mark it with a 0, and then you can just do the same thing. If you must pass through a point, split the journey into 2 parts, right? From the start to the middle, then from the middle to the end, right? So that is the second type of counting problem, right? Our shortest path. Now, the third type of counting problem is everybody's favorite topic, right? Which is listing or enumeration, right? So enumeration or number splitting, that means how many ways can we write a number as the sum of whatever, right? So let's take a look at the first question, right? This is a number splitting question where a lot of students, no matter how many times I teach, they might still get confused. So let me take this chance to review with you once again, right? So let's read the question, because when it comes to counting, right, like your addition and multiplication principle, your shortest path just now, one important key detail is to always read the question and look for hidden rules or conditions, right? For example, can you repeat the digits or not? Right, or even number, right? Pass through a point, don't pass through a point. Over here, let's take a look at this question and see what are the hidden conditions. Now, how many ways are there to make a sum of 13 using 3 different positive whole numbers? Wow, I tell you, this single sentence already has 4 hidden conditions, right? What are they? Number 1, of course, you need a sum of 13. Your total of the 3 numbers have to be 13. Right. Number 2, you are using 3 different numbers. So for example, can I say 1 plus 1 plus 11 equals 13? Is that a way? 1 plus 1 plus 11. Right. 2 plus 9 plus 2. Can I? Remember, when I say different numbers, you cannot repeat them. Now, I don't think I can understand. Just read the question carefully. Right. First, we want 3 numbers. They must be different. They add up to 13. So it cannot have repeated like this, right? This is wrong. This is wrong. All right. Is the answer 7? Not quite. Right. Try again. Next, the question also wants positive whole numbers. Positive actually means it must be at least 1. Now take note, sometimes the question will allow the use of 0, sometimes it won't. So you need to pay attention to the question. Here, cannot have 0. Finally, the same numbers in different orders are treated as one way. In other words, for example, I have 2 plus 4 plus 7 equals 13. I have 7 plus 2 plus 4 equals to 13. I have 4 plus 7 plus 2 is equal to 13. Wow! These are 3 ways, right? But, however, I am using the same numbers in each way to form the sum, so they are counted as the same. All right, so with that, right, this is how the question should be understood. And since the order of the numbers doesn't matter, right? Because 247 is the same as 472. How should I list out to prevent any repeats or missing out anything? Right? This is Teacher Yonglam's advice. We always list in order. A lot of you when you do this, you don't list in order. That's why you often repeat yourself or you miss things out. Right? And we always list small to big. So remember, 13, I need to split into 3 numbers, right? So then let's consider small to big. What's the smallest number that I can split out of the 13? Can I use 0? Cannot, because it's positive. So I have to start from using 1. Okay, so let's say I use 1 as the first number. If 1 is the first number, what's the next number? Can it be 1? Right. I want to list out a second number to form the sum. Again, remember, small to big. So can it be 1? If I already have a 1, can I have another 1? Cannot, okay, it should be the next number, which is 2. Because remember, my numbers have to be different, right? 1, 2, the last one is what number? 13 minus 1 minus 2, 10. So you see, 1, 2, 10 is away. All right? Now, does that mean this is the only way? No, we keep on listing. while keeping the first number constant? Can it be 1? And then I increase the second number by a bit, plus 1. 1, 3. Here I minus 1. 1, 3, 9. Possible, right? 3 different whole numbers that are positive. And they add up to 13. Next one, 1, 4. I make this number bigger, which means the other number has to be smaller, right? So 8, no page. Okay? 1, 5. Make it smaller. 7, 10. 1, 6, 6. Yes, definitely possible, right? 166 is possible. Good. Is this correct? Can I have 166? Cannot, because remember, I want 3 different numbers. 6 and 6 is a repeat. Get out, right? Cannot have this. So up till now, I have 4 ways. All right. Now with that, let's take a look at the next consideration. You might think, Teacher Yonglam, I can just stop here. Nope. Just now, the smallest number is 1. But what if the smallest number is 2? Okay, now this number is 2, right? Can I choose 1? 2, 1, something? Cannot, because let's say I do choose 2, 1, something, right? 2, 1. The last number will be 13 minus 2 minus 1, which is 10. And would you look at that, right? 2, 1, 10, and 1, 2, 10. They are the same, right? They are the same numbers in different order. So in the same way, I shouldn't double count. So let's remove this, right? It cannot be 2, 1, 10. Also, I cannot have 2 as my next number, right? Because 2, 2 is a repeat. That means I must try 3, right? Take note. When I choose the first number, the next number will always be 1 more than it. You see? 1 and then 1 more than it. 2, 1 more than it. We always start like this. So 2, 3, and the next one is 8, right? 13 minus 2 minus 3 is 8. Okay, stop spamming. Can we try the next one? 2, again, make this number bigger, make this number smaller. 2, 4, 7. 2, 5, 6. Haha, I have already listed some more ways, right? And 2, 6, 5. Is it correct? No, right? Because one thing is that the numbers are not in ascending order. Go up and go down. Second, 2, 6, 5 is just a repeat of 2, 5, 6. So I can remove it. And there's no point continuing, right? Because the next one, 2, 7, 4 is still a repeat, right? That's why if you list in order, there is one more advantage. The moment you hit an invalid choice, it's high likelihood that the next one will not work as well, right? Unless you are talking about 3-digit numbers, like our last mock paper, right? So then there are 3 ways over here. Now, can Teacher Yonglam stop here? Should Teacher Yonglam stop here? Cannot, right? Because what if the next number, the next case, the smallest number is 3? 3, the next one, what should I try for the second number? If I start from a 3, the next number I can start is 3, make it 1 more, right? 4, 6. Then 3, 5, 13 minus 3 minus 5, 5. Oops, it's a repeat. So unfortunately, I cannot have this case as well. Okay. So there's only one way. Okay. Now let's take a look at what happens if I increase the first number to 4. Then it will be 4, 1 more than that. Remember, I cannot continue with 4, right? I must make it more, right? List it in order. So I have 5. 13 minus 4 minus 5 is 4, right? So cannot, because there's a repeat. So at this point, this case, your first number, 4, is already too big to have any valid cases. So I don't need to consider further. I just need to count the existing ways, right? These are all I have, and there won't be any missing, right? So in answer, 4 plus 3 plus 1, there should be 8 ways. Okay, right? So remember, list everything in order so that you can get to your answer more safely. All right. So now, Teacher Yonglan has 2 more questions to go through, right? Because enumeration is really, really important, right? I have to go through all of them, right? So let's hang in there. We look at the next question. Now, sometimes the question will give you some weird definitions of some of the numbers, right? They are not just asking you how many combinations there are. They want you to form specific numbers. Now, this is what we call ascending numbers, for example, right? In ascending numbers, for any two neighboring digits, the digit on the left is smaller than the digit on the right. For example, 1, 2, 3, 4 is an ascending number because those on the left is smaller than the one on the right. Left smaller than right. Left smaller than right. Now, 1, 1, 1. Oh, sorry, this is a bit too slanted. 1, 1, 1 is not an ascending number. Neither is 1, 2, 1. Because, right, we want the left to be smaller than the one on the right. In other words, in a single number, the digits must go small to big. And I cannot have any repeats. All right? Now, with that, how do we do this question? Of course, we need to list out, right? We list out by considering how many digits can this number have. Now, first of all, can this number be a one-digit number? Oh, at the end cannot times 3 because the order doesn't matter. Okay, in the question just now, after I calculated, I don't times 3 or times 6 because this order is just one way. Changing the order is still the same way. Right. So back to here. We want to label the place values. Now, can it be a one-digit number? Cannot, right? For any two neighboring digits means that your number must have at least 2 digits. So then let's start from 2-digit number. And like I said, we always list out small to big. So list it in order, right? So let's consider the smallest tens digit, 3. Right, this is the tens, this is the ones. Now anything on the right must be bigger than it. So what's the smallest that I can start from? Of course, list in order. Don't tell me 38, 39, 35. List in order, start from 35. Then 38, then 39. Okay, am I done? I'm done with 3. But what if it's 5, right? 51. 58, 59. Cannot 53, yeah? The number on the right must be bigger. Then we also have 89 and 90. Uh-oh, 9 is already a biggest digit. I cannot have a digit larger than it. So I'll just stop here. All right. So 2-digit numbers, there are 6 of them. Right? Does that mean my answer is 6? Does that mean my answer is 6? I see some of you already talked to me in the chat. Teacher Yonglam, the answer is 6. Is it 6? Right? No. Because did I mention in the question how many digits there are? Did I mention in the question it is a 2-digit or 3-digit number? No, right? So I will have to consider by cases. It could be a 2-digit number, but it could be larger than that, right? It could be a 3-digit number, which means now I need to consider hundreds, tens, and ones. Again, list in order, right? Let's start from the smallest digit on the left. 3, 5, and what can I put here? 3, bigger than 3, choose small to big. So I label 5 first. Then here, any digit bigger than 5, we have, right? 3, 5, 8. Then 3, 5, 9. Okay, once we are done, it's time to move on to the next digit, right? But do I change the hundreds place to 5 directly? Should I change the hundreds digit to 5 directly? Think about it. Did I miss anything? Did I miss anything? Right. So teacher Yonglam's hint here is whenever you have to change a digit, start by changing the ones with a smaller or rather on the right. Right. Don't change the ones on the left first because these are more powerful. Right. Your hundreds is like your king, right? It carries a bigger value. 100 is bigger value than 10. So let's try to change your tens first. 300 and something else. What can I put here? After considering 5, try 8. Right, 3, 8, 9. Okay, then there's no more. Can I try 3, 9? Oh, I'm stuck. It is at this moment when you are completely stuck. By starting from 3, you start from 5 instead. 5, 8, 9. And yeah, this is actually the last one. You can't have 590 something. You can't have 890 something. So you just stop here. Right. But am I done? Am I done? 2-digit, 3-digit, am I done? No, because what if I have 4-digit number? Now, 4-digit number involves your thousands, hundreds, tens, and ones. And since we are given 4 digits, there is only one way to fill it up, which is 3, 5, 8, 9. Right, so there's one 4-digit number, and just now 4 3-digit numbers, which are ascending. All right. Now I cannot have 5-digit number because I'm only given 4 digits, and by the definition that the ascending numbers must be smaller to bigger, right? Then there must be, non-repeating digits. So it's 6 plus 4 plus 1 equals 11. My answer, 11 ascending numbers. All right, so that is how you do this question. Remember, consider different cases and list out small to big. Okay, so yeah, that's how you do this question. List in order. With that, let's continue with our next question, which is the last question of the day. Right, now this is another type of enumeration problem. I'm not forming numbers, right? But let's read how it goes. There are 3 red marbles, 4 yellow marbles, and 5 white marbles in a bag. How many possible combinations are there? Combination means, right, mixing of marbles, right? Groups that you can form if Mandy randomly selects 6 marbles, right? So the 6 marbles can consist of 3 colors, right? You can have your red, you can have your yellow, you can have your white, right? You can have your red, yellow, and white. And I don't care, right, how many red, yellow, or white marbles there are respectively, as long as the total number of marbles is 6. Right, I just randomly select 6 marbles. They could be red, yellow, or white. Now, in that case, how do we do this question? Now, again, we consider different cases, right? So, looking at this problem, right, which one color should I start from? If I want to list my cases, it should be because a certain color, I cannot reach too many values, right? It could be some number, it could be some other number, but not too many, right? Then I choose them to list my cases. For example, there are 3 red marbles. So if I draw marbles from the back, how many possible number of red marbles can there be? Okay, so 3 red marbles. If there are 3 red marbles in the back, I could draw out 0, 1, 2, or 3 red marbles. 4 yellow marbles, that means I could draw 0, 1, 2, 3, or 4 yellow marbles. 5 white marbles, I could draw 0, 1, 2, 3, 4, 5 white marbles. Right. There are 3 cases here, right? Or rather, 3 colors to choose to split my cases into. Would you like to consider less cases or more cases to be faster? To be faster, would you consider less cases or more cases? Of course, you would choose to list out less cases, right? Because if you have less cases, you don't need to list out that many, right? So you don't need to list out that many groups. So of course, we choose to split the cases by the red marbles, which means you could get 0 red marble, 1 red marble, 2 red marbles, or 3 red marbles, right? The remaining, we should just consider case by case. So let's quickly consider case by case and then end it here, right? Let's go. Case 1. Let's say we have 0 red marbles. That means how many yellow or white marbles are there? Yes, there should be 6 yellow and white. The total number of yellow and white should add up to 6. Right. And how can we draw out the marbles? Okay, take note. Why it can be 0 here? It's not 11. It could be 0 because I didn't mention I must have 1 red, 1 yellow, 1 white. Sometimes the question might mention you must have at least 1 of each color, so you cannot have 0. But here the question didn't mention that. If the question says must have at least 1, then yes, your lowest number is 1. So here my lowest number is 0. Of course, for yellow, lowest number is 0 as well. 0, 6. Hey, can I have 0, 0, 6? 6 white, possible? Not possible, right? Because while you do this question, you can list out everything you want, but you still need to make sure, does it fit what the question says? The question says you only have 3 red, 4 yellow, 5 white. How could you get 6 white? Cannot. Right, so this case is out. But 0, 1 yellow, 5 white is possible. Right, notice teacher Yonglam is listing everything in order. 0, 1, 5. Then 0, 2, 4. 0, 3, 3. Everything is possible, right? I have within range for my yellow marbles, within range for my white marbles. Similarly, 0, 4, 2, possible. 0, 5, 1, haha! 0, 5, 1, possible or not? Not possible because I have only 4 yellow marbles. Wow, some of you give me the answer already. Right, Ivan, good. Your answer is correct. Okay, so yeah, I cannot have 0, 5, 1 because I only have yellow marbles. There are 4 of them. Right, I cannot have 5 yellow. In the first case, I noticed there are 4 such combinations. Right, combination means as long as you tell me how many of each color, that is enough. Now, in the next case, case 2, 1 red marble, that means my total number of yellow and white is how many? I should have a total of 5 yellow and white marbles. So let's continue again. 1, 0, 5. Take note, this time my numbers don't have to be ascending because different numbers referring to different colors, right? I could have 1 red, it doesn't affect 0 yellow. It doesn't affect. I could be unlucky and get 0 yellow. So it's fine. So the order is playing a different role. 1, 1, 4 also can, right? Keep listing. Small to big are 1, 2, 3, right? This one, small to big, that means this one need to decrease at the same time. 1, 3, 2, 1, 4, 1. Remember, I have at most 4 yellow marbles, so I will stop here. I have at most 4 yellow marbles, so I'll stop here. So they are 5. Okay, let's continue with the next one. Right, again, how many yellow and white marbles are there in total? If I have 2 red, 6 minus 2, yellow and white, there should be 4 of them in total. So we can start listing. Small to big again, 0, 4, 2 red, 0 yellow, 4 white. Then continue to 1, 3, 2, 2, 2, 2, 3, 1, 2, 4, 0. Just nice. My yellow reaches 4, so I can stop here. There are 5 ways. Okay, last one. Maybe you try. Right, case 4. 3 red marbles. That means my yellow and red add together. Sorry, yellow and white add together should have 3 of them. Right, how many ways are there to split the 3 marbles between 2 colors? Right, so it is 3, 0, 3, 3, 1, 2, 3, 2, 1, 3, 3, 0. 4 ways in total, right? Remember, I cannot have 3, 4. 3 plus 4 is 7 already, right? I have 6 in total. All right. So with that, you have 4 plus 5 plus 5 plus 4 equals 18 ways to form a combination of 6 marbles. All right. And that's how you get this question done. Now, listing, like what I did just now, is honestly very tricky, right? Because you need to read the question carefully and identify all the hidden conditions. Like here, when I say 5 white marbles, that means you cannot have 6, right? When I have 4 yellow marbles, that means you cannot have 5. But as you read the question very carefully, always refer to the question and think about the constraints, think about the limit, then list everything in order very carefully. Don't ever jump here, jump there. Then you can do this question successfully. All right. Now, with that, that will be the end for today, right? Thank you for staying with me, right? We have gone through a lot of different counting techniques. And yeah, hopefully this can help you improve in your post-class practice as well as the mock test, right? I will post a new mock paper on this coming 6 p.m. Okay, and do take note, we have an offline mock test as well, right? For those who still don't know, we have an offline mock test at Tai Seng, Clementi, or Orchard. It will be on 16th of August, right? So do check out on that, right? So with that, that will be the end of today. And thank you, everybody. I'll see you next week. Okay, we have around 1 month left, right? All the best. Okay, so yeah, if you have any questions, feel free to type to me here or raise it in the group chat, right? I'll be answering to the best of my ability, right? Otherwise, I shall see you when I see you again. Okay, goodbye, everybody. Bye.